G'day, welcome to another one of Mr. Pearce's demos. This week we are looking at how to make a DIY guitar pickup. Okay, first we'll start with a piece of 3.5mm plywood. You can see I've marked off with a square the first piece. This, from memory, is about 75mm long. As long as it's well over 60mm, that's a perfect size for a pickup. I've now marked out two 75 by 25mm pieces of plywood. Most importantly, you can see I've included a wee gap because I know that that is the thickness of the saw blade I'm going to use. I've marked out where the waste side is, and the best saw to use would either be a handsaw or possibly the bandsaw if you use a guide, as long as you keep those lines straight and nice and neat. What I've done here is I have marked a cross from corner to corner on both pieces. It's not necessary that you do it on both pieces, but that illustrates clearly where the middle is, and very important when we go to look at starting to drill out the spaces for the magnets. What I've done here is I have marked out a center line. Now it's very easy to do because I've got both centers of the piece of wood. Of course I could have measured that, but it's pretty easy to mark a center through both centers of those two crosses. What I've clearly done here is I've marked out four 10mm intervals with my steel rule. You can see the center there where the X was formed. What I've done is I've set the ruler to 2.5, that's my center, 5mm either side of that, I have my first mark. Then it's another 10mm. So just to clear that up, it's 40mm overall, and it's 2.5 to the center, and those are 10mm intervals where we will be putting our 6mm diameter magnets. I've cut both pieces out now. This is the bottom piece, and there are two little dabs of hot glue. Here you can see that I am sticking down the top portion of the pickup on the two little bits of hot glue. Here you can see that I have the bottom and the top portions of the pickup plate set up on the drill press. I have a 3.5mm drill bit, which is for the pilot hole to help guide the next size drill bit into the four little marks that I've drilled out. Apart from being an accurate way to drill, a pilot hole stops the plywood, which is quite fragile, from splitting. Here you can see that I have drilled out two of the holes. Very importantly that you mark the holes out, because if they are ill-aligned, they're going to look ugly and slightly affect the performance of the pickup in relationship to the strings. This slide illustrates the fact that we have a 6mm diameter rare earth magnet, very strong, powerful magnet. It is 15mm long, as I said, 6mm in diameter, therefore we have a 6mm diameter drill bit. Very importantly that they are both the same diameter, because we want a very snug fit, and 6mm diameter object into a 6mm diameter hole will be very snug, especially in the plywood. Here you can see that I am enlarging the hole to fit the magnets in. There's the 3.5mm pilot hole, there's the 6mm magnet hole. Here's a test fit just showing how the magnet snugly fits into the 6mm hole. You don't want any slop. It's vital to holding the top plate and the bottom plate of the pickup together when we turn it into a bobbin, and wind some copper wire onto it. Okay, all four holes are now drilled out. What this slide demonstrates is that I've got my first magnet in, and then I have all the magnets stacked on top of each other. Of course, they're stacked on top of each other due to the magnetic pull throughout all three of those magnets. This illustrates North Pole and South Pole. It's important that you stack the magnets or check the polarity so that the North Pole is always on top of the magnet. We want them the same way around. Easiest way to check is that if you put the magnets on top of each other, they should attract rather than repel. You can see that I've drilled out all 4 holes and that the magnets fit really snugly in those holes, and we can turn it into a bobbin. But of course, before we can make the bobbin, we've got to split the 2 pieces of the pickup apart. In this case, you can see that I've just used a steel rule, got it started on the corner and prized apart the 2 halves, because of course there's a little spot of glue on each side of the pickup covers. Here you can see that I've got the bottom plate and the top plate, and I have pushed them apart as far as they'll go. Because these are a 15mm length magnet, 3.5 and 3.5 should leave me with 8mm gap. Here you can see that I have a 5mm diameter bolt. It's irrelevant what size it is, as long as it has a flat head, and the flat head should span 2 of the magnets. That will help it stick down nice and square, because it's vital that the spindle, which I've now created onto the bobbin, is perpendicular and central. If the bolt is off center, what will happen is when we go to spool it up with the copper wire, it will rotate off center, off its axis, and basically wobble around and make a huge mess. Just to stop the bolt moving, as part of the spindle, I've added a couple of bits of hot glue that should hold it securely in place, but of course we will be able to rip off the bolt when we need to. Here you can see our copper wire. That's very fine wire, basically no bigger than a strand of hair, and you can see that we are ready to put a couple of wraps onto our bobbin. It's not a pickup yet, it's still a bobbin. As part of this project, rather than using a normal reel of copper, we recycle it from some old power transformers. It's vital that you clean off the end of the copper wire, because it has some lacquer which will stop the copper wire from actually rusting or oxidizing. So we've got to clean that, because it's super vital that we have a clean electrical connection. I'm being a bit lazy here and using some 120 grit abrasive paper. Really you should be using some very fine wet and dry sandpaper, maybe around about 300 grit. So this is the top of the pickup. What I've done here is I have put a little bit of masking tape, and I'm going to stick down the start of the copper wire before I start to put a few turns on it. You can see here that I have put a couple of hand wraps of copper wire onto the bobbin. On a commercial pickup, we're looking at maybe 7,000 wraps of copper wire, but in this case we'll limit ourselves to just enough to get a sound. Very tedious, and commercially a special winder is used, but we're going to use our old friend the Hitachi power drill. You can see here I've stuck the bobbin in the jaws of the Hitachi power drill, and we're ready to get it to spin. Important obviously that you get it going around the right way and you don't unwrap the initial wraps that you put on. The main thing to do is keep it nice and slow until you kind of get your speed up. Possibly the worst thing you can do is to, when you're winding the copper on, to overlap and actually go outside the bobbin. Very easy to do. Take it slow. There's about 1 million different ways you could wrap this copper wire on. You're just going to have to work out what suits you and go at your own pace. So you can see in this slide that I have a few wraps of copper wire, not nearly as many as I would normally do if I wanted to get a nice full sound, but enough for illustrative purposes. So here's my bobbin with say about 50 wraps, and I'm ready to take off my little spindle that I put on it. Should be easy because I've only hot glued it and the magnet's holding it nice and square. What I've done here is I've drilled 2 holes, and they're with the pilot hole, 3.5mm, and they will be the holes to attach these little solder lugs, which are pre-tinned and really nice to solder to. So I've just put a very small screw. It should self-tap into those pilot holes. You should observe that I have put a slight kink in that solder lug, and that will allow the solder lug to anchor against the edge and stop it from spinning around too much. Obviously it's a very quick connection and nothing more than a quick fix. Commercially you'd want something that does not move around. Here you can see that I've got both of the lugs screwed on, and you can see this is the start of the wrap that I did, and this will be the end of the wrap that I did. So obviously it has started here. I've cleaned off some of the resin or lacquer on the wire. It has gone round and round and round the pickups, and now needs to be soldered onto both ends. Very important stage here, and before you should solder on the copper wire, you should check that you've actually got a circuit. Obviously I've got one of the probes here and one of the probes here from a multimeter, and I'm checking the resistance value. Here's the multimeter that I'm using. What I've done here is I have set the dial to 20 ohms. At the moment the reading is 1, which means that I have no resistance there, and in fact it tells me that there is no connection, so I better put them on the terminals properly. This is the reading I'm after. It's not a terribly good resistance reading, but at least this tells me that I do have a completed circuit. Obviously if you've gone to the trouble of winding your copper wire, you do want to actually have a fully completed circuit, otherwise your pickup will not go. In this case the value is 0.01. Good reading is anywhere up to 0.7. Obviously it's a very low resistance value, but it will be enough to get us a nice guitar sound. So bearing in mind that I've checked my resistance, I know I've got a decent connection, I've now soldered on another piece of wire that will be able to be hooked up to our guitar. Just something to point out, make sure your wires are obviously stripped, they haven't got the lacquer on them. They both get poked through the hole, and then put your hookup wire on here. It's helpful to have one red and one black to differentiate the 2 poles. Here's my final check, and in fact by putting those 2 solder lugs it looks like I've actually increased my resistance in the end, but this is just the last check. It's important to find out whether there is a completed circuit, otherwise you'll be testing it to no avail and we won't know what the problem is. But in this case we know we've got a decent connection here and we're ready to test the pickup. Here's the pickup in situ on our mock-up guitar. You can see that I've got 2 little alligator clips, one here and one here, that have connected up the pickup, and I've got an adjustable saddle here that can raise and lower the pickup. We want to get it pretty close to the strings. You want it as close as you can get without it fouling on the strings there. You can see our little setup here. We have got an overdrive pedal that will basically act as a preamp before we go to the amp, give it a bit more volume because we've only put a few wraps on it. It will be very quiet. There's our little pickup and our Samick 15 watt amp over there, and our test guitar. A little bit of feedback there. A little bit of feedback there.